guys, welcome back to my YouTube channel. Let's crack real math. My name is Viraaj, and in this video we'll be having a look at discrete random variables, but the second part of it, that is, which includes expectation, variance, and standard deviation. So if you've not watched the part 1 of this particular topic, then I would recommend you go and watch that first, because all that will be done in this video is a continuation of part 1. Basically, all of those skills will be necessary in order for you to understand this video. So without any other delay, let us begin. Right, so the first aspect which we're going to be having a look at is expectation. Now, what's expectation? In terms of numbers, if I was to represent it mathematically, it's like this. Expectation is annotated like this. It's equal to the summation of x into the probability of x when it's x. This is how it is mathematically, but to have a clear understanding, let's have a table. Let's make a table. We have x over here. Let's draw a line. Have p of x over here, and then we have our different sets of values. Let's say this is 0, this is 1, this is 2, this is 3. And let me just make up some probabilities. Let's say this is 3 over 10, this is 1 over 10, this is also 3 over 10, and then this is also 3 over 10. Because if you add all of them up, it will eventually give you 1, and that's what you want. The sum of everything over here should be 1 at the end of the day. So when I'm saying that I want to find the expectation of this particular group of data, what I will do is simply take my x values, which is 0, 1, 2, 3, and multiply it with the corresponding probability of it and sum them all together. So eventually I would have something like this. If they ask me to find E of x, which is expectation, this is simply now 0 times 3 over 10 plus 1 times 1 over 10 plus 2 times 3 over 10 plus 3 times 3 over 10. And whatever I get as my value, that would be my expectation of this particular example. I'll just quickly do this in my calculator. This is 0, we know, so 1 times 1 over 10 plus 2 times 3 over 10 plus 3 times 3 over 10. This is 8 over 5. 8 over 5. Or if you can also write it in decimal places, in terms of decimal places, that's 1.6. So that's the expectation. Now, another way they could ask you a question, instead of having x over here, they could ask you find something like this. Now, the trick to this is, whenever they give you something like this and it's only an integer inside, a whole number integer, then your answer is simply the integer itself. So the answer for this would just be 3. The answer for something, for example, E of 9,999 would also be just 9,999. So that's how that particular format works. Another way they can ask you questions is they could give you something like this, E of into 5x. So what you do in this sort of scenario is that you simply take your x values again, which we have as 0, 1, 2, and 3 over here, and simply times that by 5 before timesing it by the corresponding probability. So I'll just do one example here because we have other examples to look at. Let me just take this value of 2 over here for this one. So I would do 5 times 2, 5 times 2, and then times that by the probability of that one, which is, I believe, 3 over 10. Yeah, 3 over 10. So this would eventually become 10 times 3 over 10. Cancel, cancel, this will be 3. And then you do the same for the other ones and you add them all up together. And lastly, another way they could ask you is by doing something like this. Let's say 5x plus 3. And the quickest way to do this is, you know your e of 5x, which we would have gotten over here if we completed this. Simply take that and add your e of 3, which is this over here. So essentially, you just broke this into two different parts. E of 5x plus e of 3. And that's another quicker way to do that particular type of question. So that's for expectation. Expectation, or they could ask you expected mean, or they could ask you expected value. These three, they all mean the same thing, just different ways of saying it. Now the other part that we have here is variance. Variance, which is often denoted as var of x. Now to find variance, there's a general formula, that is var of x is equal to e of x squared, like this, minus e of x all squared. So at first it may look like these two are the same thing, but they're not. In this one over here, you would have to take your x value and square it before timesing it by its corresponding probability and adding up all of them together. While this one over here is simply your expectation or your expected value and just square that. So that's for variance. And then for standard deviation, let me just say SD. Standard deviation is simply the square root of your var x, of your variance. So once you have your variance, they can ask you for your standard deviation of that question, and that's simply the square root of your variance. So let's go and dive right ahead into our first examples. Right, here's example 1. So they've given us the probability distribution table for this one, so that's a bonus. We can see maybe it's about a die or a dice, we don't know, but we have our x values, 5 of them, and we have the corresponding probabilities as well, and all the probabilities add up to 1. So that means this table is correct. They don't require us to fill in any other particular values. First question says find e of x. Now, as I said before, to find the expectation, all you do is you take your x value, multiply it with the corresponding probability, do the same for all of the values and add them up together. So this would be e of x equal to that's minus 1, so minus 1 times 1 over 5 plus 1 times 1 over 5. You may notice I skipped 0 times 1 over 5 because I know that's 0 times 1 over 5 because I know that's 0, so there's no need to put that in and waste space and waste time, so you can skip that, plus 2 times 1 over 5 plus 3 times 1 over 5. And you can go ahead and punch this into a calculator. This particular topic does require you to use your calculator very carefully. Fast, but be careful, because any sort of misinterpretation of any sort of digit can lead you to a very wrong answer and eventually ruin your entire work. So let's do that real quick. It should be 1. That's what my mental math says. Let's see. Times 1 over 5 plus 3 times 1 over 5. Yep, it is 1. So the expectation for this is 1. Note that expectation, the value for that can be anything. It doesn't have to particularly be 1. In this case, the value was 1, but it can be any value. So please don't be thrown off by that. Part II says find var of x, so find variance of this question. Now, from our formula, as I said before, var of x is equal to the expectation with the x squared minus the whole of our expected value all squared. So this one is simply our expected value, so we can just put this over here and we'd have minus 1 squared. It's this part that we need to find. So now we need to square all our values for x and times them by their respective probabilities. So for here we would have to begin with minus 1 squared times 1 over 5 plus 1 squared times 1 over 5. Again, I skipped the 0 because if you square 0, that's still 0, and if you times that by 1 over 5, it will still give 0, so no need to put that. Plus 2 squared times 1 over 5 plus 3 squared times 1 over 5 minus 1 squared, because our expected value over here is 1, as we got from part I, and we'll just square that, subtracting it. So go ahead and put this into your calculator again. 1 over 5 plus 1 squared times 1 over 5 plus 2 squared times 1 over 5 plus 3 squared times 1 over 5 minus 1 all squared, and that gives me 2. All of this gives me 2. The first part, that's from this point here to this point here, gave me 3, and then minus the 1 squared. 1 times 1 is 1, so 3 minus 1, and that's 2. So my variance for this question is 2. My var of x is 2. And the third part says find the standard deviation, and as I said before, standard deviation is nothing but the square root of your var. So in this case it will be square root of 2, and this is plus minus 1.414 to 3 decimal places. The question can specify if your standard deviation value is positive or negative, but just to be safe, always include the plus and minus. So that's the solution for that question. On to the next example. Right, so this one says a box contains 10 pens, of which 3 are new. Okay, good to know. A random sample of 2 pens is taken. That means we have 10 pens in which 3 are new, and we're picking 2 out of the 10. Part I says that show that the probability of getting exactly 1 new pen in the sample is 7 over 15. So we need to prove that from our 2 picks, the only chances of getting 1 new pen is 7 over 15. The best way to go about this question is with our tree diagram. So constructing our tree diagram for this, I can say we have something like this. This is my new pen, this is my old pen, and this continues, and because it's just 2 picks, we can just end it on our second branch. It's new, old, new, old. The probability of picking a new pen is 3 over 10 from our first pick, because it said 3 pens are new and there are 10 pens in total, and then for old would be 7 over 10, because 1 minus 3 over 10 would give you 7 over 10. Now for the next part, if my first pick is a new pen, what's the probability of me picking another new pen? That would be 2 over 9. Because I picked a new pen, that reduces the amount of new pens from 3 to 2, and the total number of pens also reduces from 10 to 9. And then to find the probability of me picking an old pen after picking a new pen, we can simply do 1 minus 2 over 9, which is 7 over 9. For the next one, we have what's the probability of me picking a new pen if my first pick was an old pen. That would be 3 over 9, and then 1 minus 3 over 9, that would be 6 over 9. So these are my probabilities. So we haven't solved the question yet, but this gives us a really good representation of how this scenario works. Now it says show that the probability of getting exactly one new pen in the sample is 7 over 15. So how can we get one new pen? Our first pick can be an old pen, and then our second pick can be a new pen. That's one way. The other way is that our first pick can be a new pen, and our second pick can be an old pen. So going about it both ways, if I say my first pick is an old pen, that's 7 over 10, and then my second pick is a new pen, that's times 3 over 9. Or the other way it can happen is my first pick is a new pen, that's 3 over 10 times, and my second pick is an old pen, times 7 over 9. And go ahead and put this into a calculator. Let's find our value. Let's find our probability rather. And this is 7 over 15, as they stated in the question to prove, which we have successfully. Yep, we said it's 7 over 15, and that's what we got. Second part says, construct a probability distribution table for the number of new pens in the sample. Okay, so constructing our probability distribution table, let's go ahead and do that real quick. Let's let Rx be the number of new pens, and then our probability of x to that, and we can have 0, 1, and we stop at 2 because that's the maximum amount of picks we have. Now a lot of students may make the mistake of not including 0 because they're like, oh, we can get one new pen or we can get two new pens, but be careful, because you can see that there's also a chance of you getting two old pens instead of two new pens. There's a chance of getting 0 new pens. Do 7 over 10 times 6 over 9, that's you getting two old pens and no new pens, so there's a chance of that. So we know that our probability of getting only one new pen is 7 over 15, because we just literally did that question, that part of the question, where it said that was the probability of you getting one new pen, and that's what we have. The probability of getting 0 new pens, we can quickly find that out. That means our first pick is an old and our second pick is an old as well. So that's 7 over 10 times 6 over 9. 7 over 10 times 6 over 9 is 42 over 90, which is, I believe, the same as 7 over 15, yep. 7 over 15. And then to find the probability of us getting 2 new pens is simply, we can add these two up and subtract that from 1, and that would be 1 over 15. Another way you could have done this is simply go back to your tree diagram, take on your 2 new pens, that's 3 over 10 times 2 over 9, and you would have put in 1 over 15 over there as well. So that's our probability distribution table all drawn up, and that should be correct. And the last part says calculate the expected number of new pens in the sample. Calculate the expected number of new pens in the sample. Automatically, this question does require you to know expectation, and we know that the formula for expectation is simply us timesing our values of x by their corresponding probabilities. This would be 1 times 7 over 15 plus 2 times 1 over 15. Again, I disregarded this 0 and 7 over 15 because if I do 0 times 7 over 15, it would just give me 0. So no need to put that. Put this in your calculator. 1 times 7 over 15 plus 2 times 1 over 15, and this gives me 3 over 5, or in terms of decimals, 0.6. And that's the answer for that particular question. And on to the final example for today, and this is a challenge question. So do pause the video and have a go at this by yourself, and then resume the video to see if you are correct or incorrect. If you are incorrect, do take note of your mistake. Right, so let's go ahead and solve this question. It says a box, okay, contains 3 red balls and 5 white balls. Okay, good to know. One ball is chosen at random from the box and is not returned to the box. Okay, so that's without replacement. It says a second ball is now chosen at random from the box. So that means we're having 2 picks over here as well. First question says find the probability that both balls chosen are red. Right, so we have a box that has 8 balls in total. 3 of them are red, 5 of them are white, and one ball is chosen at random and not returned, and then a second ball is chosen at random as well. Right away I can see that this is a question that requires us to draw a tree diagram to help interpret it a lot easier. So let's go ahead and do that first. So this can be our red ball, and this can be our white ball, and the probability of getting another one of those two from our first pick. Again, just stop here because it's just 2 picks that is required. Probability of picking a red ball from our first pick is 3/8, because there are a total of 8 balls and there are only 3 red balls as stated in the question, and then for the white ball is 5/8. Now, if my first pick is a red ball, what's the probability that my second pick is a red ball as well? This would be 2/7, because the amount of red balls reduces from 3 to 2 because I picked a red ball, and the total amount of balls also reduces from 8 to 7 because I picked a ball. And the probability for getting a white ball, we can simply do 1 minus 2/7, and that should be 5/7. Yep, and then if my first pick is a white ball, what's the probability of me getting a red ball as my second pick? And that would be 3/7, because the total number of balls reduces from 8 to 7 because I picked a white ball, but the amount of red balls is still the same, so 3/7. And then the amount of white balls that would be picked as a second pick if my first pick was a white ball would be 1 minus 3/7, and that's 4/7. So that's our tree diagram for that question. Now the question says find the probability that both balls chosen are red. So our first pick is red and our second pick is red as well, and that is 3/8 times 2/7, and that's 6/56, which if you can reduce, I think, yep, to 3/28. Simplify, sorry, to 3/28. That's the probability of you picking 2 red balls. Next question says show that the probability that the balls chosen are of different colors is 15/28. Show that the probability that the balls chosen are of different colors is 15/28. That means both our picks must be different. So the 2 possibilities are either that our first pick is red and then our second pick is a white, or our first pick is a white and then our second pick is a red. Those are the only 2 ways both picks can be of different colors. So this would be 3/8 times 5/7 plus 5/8 times 3/7. And using a calculator to add this all up, 3/8 times 5/7 plus 5/8 times 3/7. This is 15/28. And that is what they asked us to prove. Yep, they said that show that the probability of the balls of different colors is 15/28. Right, on to the next part. Now says the random variable x denotes the number of red balls chosen. Okay, draw up the probability distribution table for x. and X denotes the number of red balls chosen. Okay, so let's go ahead and do that real quick. Let's say this is my X, then the probability of X choosing that. So we can have either 0 red balls chosen, 1 or 2, because it is a probability that there's a chance that no red balls is chosen out of the 2 bricks. There's a chance that 1 is chosen, and there's a chance that 2 are chosen. And we've found majority of them. We know that if both are chosen, if both balls are red, we found the probability of that to be 3 over 28. So this is simply 3 over 28. If it's 1 red ball, then we found that probability as well. That's 15 over 28. 15 over 28. And then for this part here, for the 0, you can just add these two and subtract it from 1. So 1 minus 18 over 28. And that should give, if I'm not wrong, 10 over 28. Yep, 10 over 28. So that's the probability distribution table done. Next part says find var of x, that's variance. Now from our formula, var of x, we know that we also need the expectation. So let's go ahead and find our expectation first. That's e x, and to find out we just simply times our x values by the probability. So 1 times 15 over 28 plus 2 times 3 over 28. 1 times 15 over 28, same as 15 over 28 plus 6 over 28. That's 21 over 28, and that is the same as 3 over 4 if I'm not wrong. Yep, it is. So our expected value is 3 over 4. And we know that our formula for var is e of x squared minus the whole, that's e of x all squared. So for this part we need to input our x values as squares. So that would be 1 squared times 15 over 28. Let's just do that. 1 squared times 15 over 28 squared plus 2 squared times 3 over 8 3 over 28 minus the square root of, sorry, the square, not square root, the square of 3 over 4. So putting this in your calculator, be careful when you are inputting the values, make sure you don't make any mistakes. This part over here gives me 27 over 28 minus 3 over 4 squared, so 3 over 4 times 3 over 4. That's minus 9 over 16. And this gives me, should give me 45 over 112. Let's confirm. Yep. This is equals 45 over 112. And that is your var of x. And the final part for this question said to find standard deviation. So to find the standard deviation, all you do is just take the square root of your variance. So standard deviation is the root of var of x. That is, it is the root of 45 over 112 This is plus minus root of 45 over 112. In terms of decimal places, it's a 0.634 to 3 dp, or you can write it as its exact value. That's plus minus 3 with 35 over 28. These are your two values for your standard deviation. Either of them is correct depending on the type of format your question wants you to leave the answer as. And that example concludes this video. Thank you for watching, guys. Hopefully you enjoy it. Please do not forget to perform an LSS, that is like, share and subscribe. Thank you for watching. Have a nice one.